That's right, babe. I'm back. So yeah, that was a longer break than I intended. Sorry about that. It's been an eventful few months. Like, for instance, I am now retired, which means in theory I have more time for hobbies like do-it-yourself synthesizers. It means I have less disposable income for hobbies like do-it-yourself synthesizers. What else has happened? I took a trip to Maine, performed at the New York State Fair, took part in January in an acclaimed theatrical presentation, put together a ukulele preamp, and most recently I've been working on some synthesizer modules, including this one. This is a nonlinear circuits timbre module. This is a wavefolder module. And if you don't know what a wavefolder is, today is your lucky day, because I'm about to tell you. So wavefolding is an important part of West Coast style synthesis as opposed to East Coast. And honestly, I never even heard the phrase West Coast synthesis until quite recently, even though I was listening to Morton Subotnick back in the 1970s, and he's about as West Coast as it gets. Anyway, I'm not a real expert, but by my understanding, one of the big distinctions is that in East Coast synthesis, as exemplified by Moog and ARP and so on, you usually start with a waveform that's rich in harmonics, like a square wave or a sawtooth wave, and you filter out some of the harmonics to make more complex waveforms, while in West Coast synthesis, as done by Buchla, you start with a waveform with little harmonic content, such as a sine wave or a triangle wave, and you perform transformations that add harmonics to make more complex waveforms. So a wavefolder is one of these modules to do these kinds of transformations. It's designed to take a sine wave input, and it does what the name implies. It folds it over. The high amplitude parts of the wave are folded over to make something more interesting. And as you turn up the folding amount, this transformation gets more and more complicated, and we'll see that later. The nonlinear circuits timbre module is based on some circuitry from one of the old Buchla synthesizers. There are two signal inputs, one of which is intended for triangle waves. It has a tri to sine converter, so what gets presented to the wavefolder itself is a sine wave converted from the triangle wave. And there's a knob to control the folding amount, which also depends on a control voltage input, and there's a knob to adjust the amount of the control voltage, and then there are two parallel outputs. So I started building this thing a while back. I bought the PC board from Nonlinear Circuits, and I sourced the parts mostly from Tata. NLC makes a front panel which is pretty basic, and I don't like it much, but Magpie Modular makes a couple of alternate front panels for this thing, which I think are a lot nicer, so I got one of them. And I got as far as stuffing the resistors on the board and discovered that somehow I'd managed not to order any 150K resistors, even though it needs 6 and I had 2. And this may have had something to do with the fact that I think I was ordering parts at about 2 o'clock in the morning. Probably shouldn't do that. Anyway, I stopped. I got sidetracked for quite a while. But recently I got back to it and I finished it up. The whole build is pretty straightforward with no real gotchas except for one. Let's see what happened when I tested it for the first time. Okay, initial test of the NLC Timbre module. What you see on the scope here is a sine wave that I've got running. Put it through an attenuator, but I've got the attenuator turned all the way up. It's something like 5 volts, plus and minus. Okay, we're going to take that and look at the output of the module. And plug the input into that sine wave source. And you can see what you get is there. What you can get is what it's kind of a, it seems to be a folded sine wave. Now this is with the controls over here turned. The control is turned all the way down. The do I have a bad connection here? There we go. That's much better. Yeah, the control, the fold control is turned all the way down. The trim pot is turned all the way down. It's still folding. If I turn down the amplitude at the input, you can see it becomes something more like a sine wave with a reduced amplitude input. So the module seems to do what it's supposed to do. If I go over here and change the fold control, it does its thing, but it doesn't go all the way down to 0 folding with a full amplitude input. So the wave folding wouldn't turn off and the output level was too low. And this sounded exactly like a problem that they warn you about in the assembly instructions, which I had ignored because they said it would only happen if your signals are more than about plus and minus 5 volts, which is what I have. Except that then I reread the instructions and it didn't say plus and minus 5 volts, it said 5 volts peak to peak. Oops. So the fix they recommended was to decrease the input gain and increase the output gain both by a factor of 2 by replacing 2 resistors, one by a smaller one and the other by a larger one. So I did that and tested it again, and it was even worse. The wave folding still wouldn't turn off, and the output level was even lower, and I said to myself, I didn't just do what I think I just did I? And I checked, and yes, indeed, I had mixed up the 2 resistors. So I had increased the input gain and decreased the output gain, which is exactly the opposite of what I was trying to do. So I got out 2 more resistors. I wrote myself a note saying which one went where, and I laid out the resistors on the note, and I carefully did the swap one more time, and this time I got it right. Alright, let's try this thing out. We've got the sine wave output from the FACO even VCO going into the timbre input. We have a control voltage going into the timbre from the AI synthesis looping ADSR. We've got one output going to the scope here and the other output going to the external audio input on the Mother 32. And we've got the fold and CV knobs turned down. And you see what's coming out of this thing. We can hear what's coming out of this thing. Is essentially a sine wave. There's a little bit of folding going on here. I think the trimmer pot in here probably could have been adjusted a little bit better than this, but this is pretty close. It's pretty close to a sine wave. Now watch what happens when we turn up the fold. It starts to fold the peak down further and further. And then things start getting more and more complicated. until eventually it kind of saturates, leaving you with a square wave output. Back this down again. Okay. And if I turn up the control voltage, we can get some voltage controlled folding going on here. Like that. Now there's one thing that isn't really working right here. If I put a full amplitude triangle wave into input 2, which is the one that has the try to sine converter, and if I turn off the folding, what I get is not a sine wave but a square wave. So my guess is the try to sine circuitry also needs some modifications for the larger signals that I'm using. Unfortunately, in this module, the jacks are mounted on the back of the circuit board directly over the solder pads for most of the try to sine components, so swapping those components out would be a real pain, but I don't actually care. The only triangle wave source I have is the Bafaco VCO, which also has a sine wave output, so why would I need a try to sine? Anyway, the wavefolder is meant for sine wave inputs, but it does do interesting things with other waveforms as well. Anyway, I don't really feel like I'm missing anything. And if I really need a try to sine converter, I can always build one separately. The other minor issue is it seems like the fold pot could have been about half the resistance, because it seems like the folding mostly saturates well before you reach the pot limit, but that is also something I can live with. So there you have it. I'm kind of excited to have this module because up until now everything I've built has been more of the same of what's in the Mother 32, maybe with more features, but the same kind of East Coast synthesis components. This is the first thing I built that's really different from what the Mother 32 can do. And I enjoyed building it. I hope you enjoyed hearing about it. And this is where I'm supposed to say like and subscribe if you did, but you know that, right? Watch for more on this channel, including a sample and hold build that did not go so smoothly, and a cheap and sleazy but fun echo reverb module coming up on Analog Output.